Welcome to video 4 of the Google ADK Masterclass. Today we are covering all 4 multi-agent patterns, one real scenario at a time, so you know exactly when to reach for each one. Why do we need multiple agents in the first place? Imagine using a single monolithic agent for every task. One giant prompt handles everything: understanding the request, gathering information, analyzing data, and generating the final response. As workflows become more complex, this prompt becomes harder to maintain, debug, and scale. Instead, ADK encourages a specialist agent approach. Just like a real-world team, each agent has a clearly defined responsibility. A parser agent understands the request, an analyst agent performs reasoning, and a writer agent generates the final output. Because every agent has a focused job, the system becomes easier to test, debug, improve, and scale independently. Once work is split across specialist agents, the next question becomes, how do these agents collaborate? ADK provides 2 orchestration approaches. The first is deterministic workflow agents, sequential, parallel, and loop, where the execution path is defined in code. The second is LLM-Driven Delegation, where the language model itself dynamically decides which agent should handle each task at runtime. Here is our first scenario: a document processing pipeline. We need to take a raw PDF, extract its text, pull structured fields, then write a summary. Each step depends entirely on the previous one's output. You cannot extract fields before you have raw text. The order is fixed and must never change. This is exactly what SequentialAgent is built for. SequentialAgent runs sub-agents one after another, in a fixed linear order. Like an assembly line, each agent writes its result to shared state using output_key. And the next agent reads it back using curly brace syntax. Use this whenever steps must happen in order. And the advantage is that it's deterministic and easy to debug. Second scenario: a market research report. We need to gather the latest stock news and the current stock price. Then combine both into one report. These 2 lookups don't depend on each other at all. Running them one after another would simply waste time. This is exactly what ParallelAgent is built for. ParallelAgent runs sub-agents at the same time. It fans work out, and a later agent gathers the results. Our news researcher and price researcher run simultaneously, each saving to their own state key. Use this for independent tasks with no shared data dependency. The advantage: total time equals the slowest branch, not the sum of both. Third scenario: blog post refinement. We need to write a draft, have it critiqued, then improve it, repeating until the writing is genuinely good. A single pass rarely produces great writing, and we don't know in advance how many rounds it will take. This is exactly what LoopAgent is built for. LoopAgent repeats the same subagents in a cycle until a stop condition is met. Our writer drafts, our critic reviews, and they repeat until the critic signals escalate equals true, or max iterations is reached as a safety net. Use this for draft, review, and refine cycles where quality improves with repetition. Fourth scenario: a customer support router. A user message could be about billing, a technical bug, or a general question, and you don't know which in advance. The right specialist depends entirely on what the user types. It cannot be hard-coded. This is exactly what LLM-Driven Delegation is built for. LLM-Driven Delegation works completely differently from a workflow agent. A coordinator agent reads each sub-agent's description field and dynamically decides, at runtime, which one specialist should handle the request. It sits as a sibling to the workflow agents in ADK's architecture. Same sub_agents list, But the routing itself is non-deterministic, decided by the model, not by your code. Let's be crystal clear about the difference. LoopAgent repeats the same fixed steps deterministically until a condition is met. It's a workflow agent. LLM-driven delegation picks a different path each time based on what the LLM decides. It's agent transfer, a completely separate mechanism. One improves a single artifact over time. The other routes to the right specialist out of many. You now know all 4 multi-agent patterns in ADK: sequential, parallel, loop, and LLM-driven delegation. In the next video, we explore state management and memory in ADK, including how agents maintain context, share information, and manage long-running workflows. Subscribe so you don't miss it.